Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Malia Forbes. I'm Marketing Coordinator for ALS North America, and I'll be facilitating the webinar today. Before we begin the presentation, I have a few helpful notes. You can type your message or question in the chat pod at the bottom right of your screen. You can also select the hand icon to notify me of your status so I can assist you as needed. All questions will be answered at the end of the presentation. Our presenter today is Jessica Helland. Jessica Helland is the project manager of the ALS laboratory in Salt Lake City, Utah. Jessica holds a Bachelor of Science in Biology. She served for 5 years as a GC chemist analyzing samples for pesticides, PCBs, TPH, and semi-volatiles. Jessica has been with ALS as project manager for 7.5 years, working on numerous large and small pesticide projects. But her expertise doesn't stop there. She is also busy managing projects for industrial hygiene and indoor air sampling clients. Today, Jessica will be discussing pesticides in air and on surface wipes. Jessica, thank you for taking the time to deliver this presentation. I'm now going to turn it over to you.
Thank you. Hello, everyone. I hope everyone is staying safe and healthy. We'll go ahead and get started on just talking about pesticides. So I'll start with kind of a basic introduction. When we use the terminology pesticides, we're talking about quite a few different classes of compounds. And so when you've got projects or when you've got industrial hygiene or occupational safety needs, you're going to see a couple different kinds of names used: pesticides, herbicides, insecticides, and fungicides. And these terminologies are used to describe how the pesticide is who it is targeting. So herbicides, for example, target plants. Insecticides, obviously, and target insecticides, and on and on. And so it's a really, really broad class of compounds. So that's part of why we wanted to discuss this in a webinar, is to kind of give you an idea of not only is this a wide class of compounds, it's something that we have a wide amount of availability for testing. One of the things I'm specifically not going to discuss today are a type of thing called disinfectants. Those are things you're probably seeing in the medical industry or in things like indoor pools and public facilities. Disinfectants like peroxyacetic acid, chlorine bleach, hydrogen peroxide. Those are actually capabilities we have for testing in occupational air and surface wipes, but that is a discussion for a different day. The other kind of definition I wanted to discuss, just for those of you who are not aware of what this acronym means, is the acronym NIOSH. And you're going to see this when I talk about the methods named. Some of you who may have some familiarity with other types of methods may be used to terminology like EPA methods or SW methods. The methods we're talking about fall under the NIOSH methods. So that's why I wanted to kind of clarify where that is. They are a research group that publishes methods specific to occupational safety and health. Okay, so if you look at NIOSH's compendium, they have a lot of individual methods for individual compounds. The couple that I've listed here are just some examples where they at one point was developing paraquat specific to HPLC. And so as companies were developing new pesticides, and as they were registering those pesticides with the EPA, NIOSH was then going, okay, well, now we need to develop a method for this pesticides. And then, okay, another one came in. And so it was just starting to get to the point where you had so many individual methods where it was taken on a piecemeal basis. But if you've ever looked at EPA's compendium of registered pesticides, it's just huge. So I believe the time frame for some of this happening was the late 90s, and there were just too many methods, too many different methods, and then too many pesticides being registered with the EPA at once, and not enough time to develop methods piecemeal. So NIOSH decided that they wanted to come up with a universal sampler and kind of a universal method, so to speak. So at the time, we were under contract with NIOSH for method development, and so they assigned us to solve this problem. So as part of the solution, we have our senior research chemist, John Reynolds, who is still on staff with us today. And he was personally assigned with kind of figuring out the solution to not enough time to develop individual pesticide methods. So he worked with SKC and did a lot of research and found that they were working on developing what they call a versatile sampler. So it was meant to capture as many different kinds of organic compounds as possible. He worked with them to give suggestions on the type of filter they might use. So I've got here on the slide a picture of this sampler. And those of you who are experienced with some of the sorbent tubes will notice it's a little different than the sorbent tubes you're used to seeing, where it's got just plastic caps on the end instead of it being completely closed off. It's got a large opening here. This is a 13 millimeter opening. It's got a filter in front of sorbent layers. So not only was this meant to have a wide applicability, it was also meant to be able to handle a decent amount of air volume, as a lot of pesticides have really low exposure level requirements. And we can go back and talk about more specifics about this sampler at the end if you have specific questions, but I wanted to kind of give you a brief picture. This picture just comes directly from the manufacturer SKC's website, and information about this sampler can be found on their website. Some things to highlight was that the resin or the sorbent material that they wanted to use was what's called XAD2. That is something that is used in a lot of other sorbent tubes. The other thing that we note is that a quartz fiber filter was chosen to help collect particulates. Pesticides are used usually in an aerosolized form, which means you're going to have droplets, and filters are also good for collecting droplets. One of the other applicabilities of pesticide exposures is in soil remediation. And so in soil remediation, when environmental companies are cleaning up contaminated soil sites that are known to have pesticides, the filter will help collect some of those particulates that could be an exposure route for pesticides. Once we had kind of come to a consensus about this sampler we wanted to use, we worked on developing a couple of methods that would be more of an umbrella method. We worked on NIOSH 5600, which is run by a type of phosphorus detector. We published that through NIOSH in '94. We worked on NIOSH 5601, which was developed for HPLC UV for a nitrogen class pesticide. So at first we were kind of targeting phosphate-based, nitrogen-based. These are all using the same sampler. So it was published in '98. And then our most recent one was a more encompassing method meant to cover a big list of pesticides that could be analyzed with what's called gas chromatography. So this is our holy grail of 5605 is the method. And I won't show the entire one, but I kind of wanted to show you an idea of what the front page of it is. You can see the sampler references OVS2, it references the XAD2. It shows flow rates and volume recommendations, and then it goes into more details on the actual analytical side. So this method has been validated by NIOSH. They do validation studies, but as of today, has not been officially published. NIOSH only releases publications every so often. So this method, unlike the others mentioned, is not available to the public online. So we have a copy of the draft form of it because we wrote it, and we are running it, and we are certified to run it. But that is, if you are trying to access it online, that's why you can't find it online. This is the method we are currently using for the vast majority of the pesticides we run, with the exception of NIOSH 5601, where we've modified it for LCMS. There are some classes of compounds we're running by those methods. And these are the air methods. There are wipe methods that we developed that are basically the same as the air methods. The only difference is specifying the sampling media. And with wipe methods, I actually don't have a slide specific to it. With wipe methods, it was more straightforward because you're dealing with just surface particulates. It's things like a sterile cotton gauze, a glass vial, and usually isopropyl alcohol. Those have technically different method references, but the analytical work and the most difficult part of it was developing the air side of things. So this is kind of covering that OVS tube. So for the vast majority of the pesticides we are capable of running, the recommendation is that 5/8 tube, the OVS tube that I showed a picture of. It's got a wide range of sampling flow rates to set your pump at, but it is designed to handle 1 liter per minute for up to 8 hours of sampling, which is really unique for this type of sampler. A lot of sorbent tubes do not have that capacity, but this is a fairly large sorbent tube and can handle that kind of capacity, which allows you to see a lot lower detection limits than you normally would with smaller tubes. And so for those who may be unfamiliar with sorbent tube sampling, the basic design is you have a sorbent tube connected to some tubing connected to a low flow personal sampling pump, and that pump will pull air through the sorbent tube. And then the tube is sent to us, the lab, and we desorb it and detect what pesticide and the concentration and things like that. As with most NIOSH methods, this is designed for personal or ambient air, mostly for indoor air. There have been projects where we've used it for occupational exposure in an outdoor setting, but there are some limitations to how effective outdoor sampling is with sorbent tubes, just based on if you have a really humid environment, a really dusty environment, or a lot of wind, that can affect things. But this is still a very applicable method for any type of ambient or personal air sampling. So here's where we go into a little bit of the wiping procedure. The wipe samples are using a pre-cleaned cotton gauze. We actually use sterile cotton gauze, and then we clean it with a solvent here at the lab. So there's a lot of background interferences, especially with gas chromatography analytical procedures. So what we do is we take sterile cotton gauze and clean it with a solvent to basically extra clean it. And so that is why we usually ask that you use the supplies for your sampling purposes that we provide, is so that we can guarantee they're clean enough to see the low detection limits that we can. And then usually the wetting agent for these is isopropanol or methanol, both of which are applicable for surface wipe testing. And then the samples are returned back to us in glass vials. Part of the reason we have to use glass is the same reason we have to clean the cotton, is that plastic bottles can have interferences for a lot of gas chromatography analytical work. And these are all supplies that ALS carries and can provide for your sampling projects. We also can provide what's called a template. It's a paper template that measures 100 square centimeters. I don't know of any specific recommendations for how much surface area to test, but this is the recommendation for the surface area we think is applicable. And so you can use that template to measure how much surface area you're testing. Okay, so before I start getting into some of these lists, we do not actually have a comprehensive list of every pesticide we are currently testing, because it is vast and because it's actually ever changing. We are very flexible with our clients' needs and are trying to take on new pesticides as clients need them. But what I wanted to go through was just some terminology for some panels that we've kind of developed to maybe help clients with if they don't know specific pesticides that they need, but they may know a class of compounds, and just to give you an idea of the types of chemicals you're seeing out there. So just briefly, this one is what are called acid herbicides. Some of these compounds may seem familiar. You may recognize the compound 2,4-D. That is the compound that is commonly used as a weed and feed for your grass. So some of these pesticides are things that you are able to purchase at a, at a garden store. Some of these are more carefully controlled than that. But so that's why some of these pesticides are going to be applicable for that. This class, these all have in common that they are in acid form. And these are compounds we can test and analyze all of these compounds off of the same sample, either sorbent tube or wipe. They all require what's called a derivatization step, meaning we have to change the form of the compound to be able to detect it. But some of these compounds may be familiar to some people as they are available in drugstores. Some of them are. Something that's also in common with these types of pesticides, they tend to break down very easily with exposure to light and sun. So they tend not to stick around a lot. That's something they do have in common. The next panel I'm going to reference is what's called organochlorine pesticides, meaning all these pesticides have a chlorine as part of their molecular structure. If you are in the soil and water industry, you may recognize this list as being the same list as the method SW8081. That's actually kind of where we came up with this list. I'm not actually sure how many of these pesticides are currently available to purchase or use, but some of you may recognize things like DDT, that was a pesticide used quite a while ago. These things, a lot of these pesticides stick around in the environment for a fair amount of time. So the majority of the projects I've done with these class of compounds are soil remediation of contaminated sites. So sites that were used a long time ago and are now doing soil remediation for. This is another pesticide list that is phosphate-based, meaning these compounds all have a phosphorus part of them. These are more that you may be familiar with, and you may see a handful of these on shelves at agricultural purchasing. These all can be tested together, either air or wipe. If you have specific questions about these, we can go back, and I can provide these lists to anyone who asks. Pyrethroids, these are definitely something you're going to see available. The interesting thing is some of these compounds are based on and have been developed as synthetic versions of naturally occurring pesticides. If I am remembering correctly, I believe it is actually chrysanthemums. There are some plants that produce their own naturally occurring pesticides that are fairly effective, and so pesticide manufacturers have taken some of those and have developed synthetic versions, or even use organic versions based around the molecular behaviors of those naturally existing ones. So this is probably one of our more commonly requested panels, is a pyrethroid based panel. And same thing, these can all be tested together. This is an example of some pesticides we're not referencing the NIOSH 5605. These are a carbamate group. And this is ones that based on what the chemistry looks like, we have to run these on LCMS. We've done a slight modification to 5601 and are running these by LCMS. But these are also compounds that can be all tested together. Okay, so I mentioned before that these panels that I showed you are by no means a comprehensive list. One of the other things we have is what we are calling screening methods. The pesticide panels that I showed previously are what are called fully quantitative, meaning we can identify those compounds and we can give you an exact concentration of of those compounds based on a calibration of our instruments. Screening methods are considered what is called semi-quantitative, meaning we run some standards, we have a library we can look at, and we can identify with a fair degree of certainty what it is, but we can only give you an estimated value. So these screening methods are what we recommend if you don't know the specific pesticide that you want to sample for or a specific class. So I've got some descriptions here. They're a little wordy. I can provide this via email for anyone who wants to look at them more detailed, but there's two versions. There's a pesticide and an herbicide, and you can just get an idea of what they may cover and what they do not cover. So this is the description I provide to people who are asking what we can do if you don't know what you're going to be testing for. I did want to bring up, because I didn't actually mention it in my slides elsewhere, glyphosate is mentioned here. Glyphosate is the active ingredient in the product Roundup. We do have the ability to test for glyphosate in air and on surface wipes. It is a standalone method, though. It does not fall under the 5605 method. It is a filter method, but if you do have a need for that, keep that in mind. We are able to test for glyphosate. Honestly, the takeaway should be for this is that ALS has a capability of testing almost every pesticide out there, specifically organic compounds. So if you have any pesticide needs and you don't see it listed anywhere, just ask. Just email me and ask. We are constantly taking on new projects and taking on new capabilities. This just goes over the sampling recommendations that we covered before. So these are the kinds of questions we will ask you when you approach us about a pesticide sampling project. If you have specific pesticides in mind that you know were used or potentially used, that's the best way to start. We prefer you have access to the chemical registry numbers, the CAS numbers if available, or MSDS sheets that will have CAS numbers. That helps because a lot of pesticides are registered under brand names or compound names, so there is some variability in the same pesticide being called a couple different things just with brands. And if you can't find a CAS number, we can still help with you figuring that out. But that is very helpful. Like I mentioned too, material safety data sheets for the products used. All pesticides should come with some sort of material safety data sheet, a description on how to use it safely. So if you have access to that, that is a great way to approach the lab with, here's my safety data sheet. Can you help me with this compound? So if you have that, just contact us directly and we'll see if that's a compound we are currently testing or can get online and help you know how to analyze it for it. If you don't know a specific pesticide, we recommend asking about maybe a class of compounds like the panels I showed before. Is this a chlorine-based pesticide? Is this a phosphorus-based pesticide? If the answer to that is no, that's where those screening options come in handy. Is if you have no idea, all you know is there is a pesticide used and you have no idea what was used, those two screening options can help you target it. And in many cases, once we've determined what the compound is, we may be able to do additional analytical work to determine concentration. So yeah, we have our list really is hundreds long, and we are regularly adding new capabilities based on client progress. Here's just some information about the location. The Salt Lake City location is the location that is doing the analytical testing for pesticides in air and surface.
Oh, Jessica, I think we lost you there for a second. This is the time where we normally open up the discussion for questions. If you have a question, you can put it in the chat box and hopefully we can get Jessica to answer those. I'll wait just a minute and see if anybody has a question. It does look like Jessica is having some connectivity issues. What I'll do is if you have a question, you can go ahead and, oh, Jessica's back.
Can you hear me?
Yes, you're back.
Yay!
Okay.
Yay!
I am opening this up for questions now. If anyone has one, they can put it in the chat box and I will relay that question to you. So far, there are no questions.
Okay.
This webinar presentation has been recorded. All participants of the webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS Global website and our YouTube channel. I encourage you to find a wide range of video resources and past Webinar Wednesday presentations there. Oh, we do have a question. Let's see. Please follow our showcase page on LinkedIn, as well as post links to future webinars and other valuable resources and updates there. Thanks for attending today. Everyone, please enjoy the rest of your week and be safe out there. Oh, Jessica, one question.
Yeah.
For the wipes, should the samples be sent in clear or amber glass?
So we are okay with either. That question probably comes from the fact that in soil and water sampling, I believe amber is recommended for most pesticides. The recommendation is to keep them still stored away from light and ship them in something like a cooler. So even though you don't necessarily have to use amber glass when shipping them, the recommendation is still once you've sampled to try and keep them away from light and heat.
All right, everybody. Thanks for joining us again, and we will see you at our next Webinar Wednesday series.
Bye.